Hello everyone, and welcome to our Maths PowerPoint presentation. Today, we're excited to explore some fascinating mathematical concepts together. On this first slide, you'll see the title, Maths PowerPoint Presentation. We'll also touch on what you can expect from this session. Over the next few slides, we'll cover key topics, share interesting examples, and hopefully make math both fun and engaging. Let's get started. Let's take a quick look at what we'll cover in this lesson. First, we'll start with the basics of triangles and their properties. Then, we'll move on to understanding the criteria for congruence of two triangles, which is essential for proving when two triangles are exactly the same. After that, we'll discuss the inequalities that can occur within a triangle and what they tell us about the side lengths and angles. Finally, we'll wrap up with a summary to reinforce what we've learned today. This structure will help us build a clear understanding of triangles and their key concepts, connecting everything to the overall theme of exploring geometric relationships. Welcome to the lesson on triangles. Today, we're going to explore what makes a triangle unique and interesting. So, let's start with the basics. A triangle is a closed figure formed by three intersecting lines. The word triangle itself comes from the prefix tri, meaning three, because, as you might guess, it has three sides. Now, a triangle isn't just about sides. It also has three angles. Those are the spaces between the sides, and three vertices, which are the points where the sides meet. To make this clearer, let's consider triangle ABC, which we can also write as ABC. In this triangle, the sides are AB, BC, and CA. These are the straight lines connecting the vertices. The angles are A, B, and C, which are the corners of the triangle. And the vertices are the points A, B, and C themselves. Understanding these key parts helps us see how a triangle is constructed and how its properties are related. Remember, these elements, sides, angles, and vertices, are fundamental to studying all types of triangles, whether they're equilateral, isosceles, or scalene. So, as we move through this lesson, keep these parts in mind because they are the building blocks of everything we'll learn about triangles. Let's look at the table first. Here, we see that angle A corresponds to angle X, angle B to angle Y, and angle C to angle Z similarly. Side AB corresponds to side XY, side BC to side YZ, and side AC to side XZ. This correspondence helps us understand how the parts of two triangles relate to each other. Now, moving on to the objectives of this lesson. We want to understand what it means for two triangles to be congruent. So, imagine we have two triangles, ABC and Zis. If their corresponding angles are equal and their corresponding sides are equal, then we say these triangles are congruent. Here's the key point. When the sides of ABC coincide with the sides of Zis, and all the corresponding angles and sides match, we write ABC is congruent to Zis, which we write as ABC Zis. This concept of congruence tells us that the two triangles are essentially the same shape and size, just possibly oriented differently. It also means that every part of one triangle, each angle and each side, has a matching part in the other triangle. And this brings us to an important term, CPCT, which stands for corresponding parts of congruent triangles. It means that for any two triangles that are congruent, all their corresponding parts, angles, and sides are equal. This is a fundamental idea because it allows us to transfer properties from one triangle to another when they are congruent. Let's take a closer look at the criteria for the congruence of two triangles, specifically the SAS congruence. As you can see from the table, the first key point is that if side AC is equal to side PQ, and the angle at C is equal to the angle at R, then these are important congruence conditions. The second point is that if side BC is equal to side QR, then we have a pair of sides and an included angle that are congruent. When these conditions are met, that is, if two triangles share a side, an angle, and another side in a specific way, then we can say that the two triangles are congruent. In this case, we write that triangle ABC is congruent to triangle PQR, which we denote as ABC PQR, by the SAS congruence criterion. This concept is fundamental because it helps us establish the equality of triangles based on these key parts. making our geometric proofs much more straightforward. Remember, the most important part here is understanding that when two sides and the included angle are congruent, the entire triangle is congruent. That's the power of the SAS criterion in proving triangle congruence. All right, let's look at this table and see what it tells us about triangle congruence. First, we have that angle BAC is equal to angle EDF. This means that these two angles are congruent, which is a key part of establishing similarity or congruence between the triangles. Next, we see that side AC is equal to side DF. This is important because when two triangles have two angles and the included side equal, it helps us apply the ASA, or angle-side-angle, congruence criterion. Moving on, the table also shows that angle ACB equals angle DFE, further reinforcing the similarity in the angles of these triangles. Putting it all together, if these conditions are met, that is, two angles and the included side are equal between the triangles, then we can conclude that triangle ABC is congruent to triangle DEF. We state this as ABC DEF, and this conclusion is based on the ASA congruence rule. So the key takeaway here is that when you have two triangles with two pairs of angles equal and the included sides equal, they are congruent. This concept is fundamental because it helps us prove that two seemingly different triangles are actually identical in shape and size, which is a core idea in understanding geometric relationships. Now, let's take a closer look at this table. It shows us the key angles and side lengths that help establish triangle congruence. First, we see that angle BAC is equal to angle QPR, and that's important because equal angles often suggest similar or congruent triangles. Next, angle CBA equals angle RQP, which reinforces this idea. Then, we have the side BC equal to QR, which is crucial because congruence isn't just about angles, matching sides matter too. Putting all this together, we can see that these conditions, two angles and the included side, match between the two triangles. This is what we call the AAS, or angle-angle-side congruence criterion. When these conditions are met, we can confidently say that triangle ABC is congruent to triangle PQR. So the takeaway here is that if these angle and side equalities hold, then the two triangles are congruent by AAS. This concept is fundamental because it helps us establish triangle congruence without needing to check every side and angle individually. It's a powerful tool in our geometric toolkit that connects the specific measurements to the broader idea of triangle congruence, reinforcing the theme of how geometric properties and criteria interplay to prove when shapes are exactly the same. All right, let's take a closer look at this table. Here, we're comparing the sides of two triangles, ABC and PQR. The first row shows that AB is equal to PQ, meaning these two segments are congruent. The second row indicates BC equals QR, and the third row shows CA equals RP. Now, what's important here is that all three pairs of corresponding sides are equal. This is what we call the SSS, or side-side-side congruence criterion. When all three sides match up in this way, we can conclude that the two triangles are congruent. So, if these side lengths are equal as shown, then the triangles ABC and PQR are congruent, which we write as ABC-PQR. This is a powerful concept because it allows us to prove that triangles are identical in shape and size just based on their sides. Understanding this helps us build a solid foundation for more complex geometric proofs and problem solving. Remember, the key takeaway here is that if all three pairs of corresponding sides are equal, then the triangles are congruent by SSS. Let's take a closer look at this table. On the first line, we see that angle ABC and angle DEF are both right angles, which means they each measure 90 degrees. This is an important starting point because right angles often help us establish congruence in triangles. Moving to the second line, AC equals DF. This tells us that one pair of corresponding sides are equal in length. Then, on the third line, BC equals EF, indicating that another pair of corresponding sides are equal. Now all these conditions, right angles, one pair of sides equal and the other pair of sides equal, are the key elements of what we call RHS congruence. RHS stands for right angle, hypotenuse, and side. So, if we know that these conditions are met, specifically, the right angles are equal, the hypotenuses AC and DF are equal, and the legs BC and EF are equal, then we can conclude that the triangles ABC and DEF are congruent. This is a powerful concept because it allows us to establish the equality of entire triangles based on just these specific parts. Remember, the RHS congruence is often easier to verify than other congruence criteria when dealing with right triangles. In the context of our overall discussion, understanding RHS congruence helps us simplify many problems by quickly identifying when two right triangles are identical in shape and size. Let's talk about properties of triangles, specifically the isosceles triangle. So, a triangle where two sides are equal in length is called an isosceles triangle. For example, in triangle ABC, if we have OB equal to BC, then ABC is an isosceles triangle. Now, a key property here is that the angles opposite those equal sides are also equal. So in this case, the angles opposite to OB and BC, namely ABC and ACP, are equal. This is important because it helps us understand the relationship between sides and angles in triangles. The sides opposite to equal angles are also equal. So, in our example, since ABC and ACP are equal, the sides opposite these angles, namely OB and AC, must also be equal. These properties are fundamental because they connect the equality of sides to the equality of angles, which is a central theme in understanding triangle geometry. It's all about symmetry and the relationships that come from those equal lengths and angles. Let's talk about inequalities in a triangle. The key idea here is that when two sides of a triangle are unequal, the angle opposite the longer side is larger. So, if one side is longer, the angle opposite it must also be greater. In this example, we see that the side with length 10 is longer, which means the angle opposite it is larger, specifically 90 degrees. This illustrates a fundamental relationship. In any triangle, the longer side is always opposite the larger angle. Now, by comparing the angles, we determine that the side opposite the larger angle, here, the side of length 10, is also longer. It's a reciprocal relationship. The side length and the angle opposite it are directly related. Finally, a very important inequality property of triangles is that the sum of any two sides must be greater than the third side. In our example, you can see that 9 plus 8 is greater than 10, 8 plus 10 is greater than 9, and 10 plus 9 is greater than 8. This is essential because it confirms the triangle's validity and helps us understand the constraints on side lengths. Together, these points highlight the intrinsic link between side lengths and angles, as well as the fundamental inequalities that define the shape and structure of triangles. Now, let's wrap up with some key points about congruence and triangle properties. First, two figures are congruent if they are of the same shape and size. When it comes to triangles, if three sides of one are equal to three sides of another, then the triangles are congruent by the side-side-side, or SSS, criterion. Similarly, if two sides and the included angle of one triangle match those of another, then they are congruent by the side-angle side, or SAS, rule. In the case of right-angled triangles, if the hypotenuse and one side are equal, then the triangles are congruent by RHS, which stands for right angle hypotenuse side. A quick note about equilateral triangles. Each angle measures exactly 60 degrees, which makes all sides equal. Here's an important concept. In any triangle, the side opposite the longer side will always be longer itself. Additionally, the angle opposite a longer side is larger, which helps us understand the relationship between sides and angles. Moving on, if two angles and the included side in one triangle match those in another, the triangles are congruent by ASA, angle-side-angle. Angles opposite equal sides are equal, reinforcing the link between side lengths and angles. And conversely, the side opposite a larger angle is longer, which again emphasizes that connection. Finally, if two angles and one corresponding side are equal in two triangles, then those triangles are congruent by AAS, angle-angle side. Remember, the sides opposite equal angles are equal to. To finish up, a fundamental property of triangles is that the sum of any two sides must be greater than the third side. This inequality is essential for understanding the possible shapes and sizes of triangles. All these points tie together to give us a complete understanding of triangle congruence and the relationships between sides and angles.